Hope you are great. Today we're going to continue chapter 4, section 3. So let's start. We take it before the first rule, which is called Aufbau principle. So what about the second rule? Second rule reflects the importance of the spin quantum number. Pauli exclusion principle. No two electrons in the same atom can have the same set of 4 quantum number. Two electrons to occupy the same orbital, they must have opposite spin state. Which is mean what? This mean if you have 2 electrons like this in orbital, the 2 electrons must have opposite spin state. So this spin state, or this 2 electrons, wrong. So we should to write or to put the 2 electrons in orbital like this. One clockwise and the second one anti-clockwise, like this. So we should to put electrons in orbital like this. 2 arrow opposite in direction, while this is wrong. This is Pauli exclusion principle. Third rule, which is called Hund's rule. Orbitals of equal energy are each occupied by 1 electron before any orbital is occupied by a second electron, and all electrons in a single occupied orbital must have the same spin state. Meaning this rule requires placing as many unpaired electrons with a same spin state as possible in separated orbitals in the same sublevel before pairing them. This means what? Look at this picture. Look at this picture in B sublevel. First, we fill all orbitals in B sublevel with a single electron. Then we pair it. So this is incorrect. I pair the first orbital in B sublevel without all orbitals are filled with one or with single electrons. For example, this is a B sublevel. If I have 5 electrons in B sublevel, so first we should to put electron single in the 3 orbitals and then pair it. So the 1, 2, 3, 4 and 5. This is right. There are 3 ways to indicate electron configuration. So we have 3 ways to write or to put electrons in orbital. First way, called orbital notation. In orbital notation, we describe orbital by line like this. Then electrons like with electrons like arrow like this. This is orbital notation. This is a way to indicate electron configuration or to put electrons inside orbital. Electrons are represented with arrow. An orbital with 1 electron would be drawn as like this. In orbital with 2 electrons would be drawn as 2 arrows here like this in a different direction. Example, hydrogen 1, atomic number 1. So hydrogen have only 1 electron. We draw like this, 1s, and only 1 electron or 1 arrow. Another example, helium 2, atomic number 2. So the number of electron equal 2. We draw it like this. Electron configuration notation. This is a second way to write electron configuration. Eliminate the line and arrow of an orbital notation. We eliminate the arrow and the line, and also use only in name. The number of electrons in sublevel is shown by adding subscript to the sublevel name. And S sublevel in the second energy level containing 2 electrons will be written as 2s power 2, 2s 2. So if I want to write hydrogen 1 electron, or atomic number 1. So if I want to write electron, or to configure electron in hydrogen by electron configuration notation, we write it like this: 1s1. What about helium? 1s2. Helium 1s2. Another example, sodium 11. If I want to write sodium, or to configure electrons in sodium atomic number 11, write it like this: 1s2, 2s2, 2b6. So 2 plus 2 plus 6, 10. We need only 1, so 3s1. So this is electron configuration notation. Hydrogen 1s1, 1 electron is present in hydrogen 1s orbital. 1s2, 2 electron in helium 1s orbital. Look at this table. Lithium atomic number 3, so 1s2, 2s1. Beryllium 4, 1s2, 2s2. Boron 5, 1s2, 2s2, 2b1. 6, carbon 6, 1s2, 2s2, 2bc2. Nitrogen 7, 1s2, 2s2, 2b3. Neon 10, 1s2, 2s2, 2b6. Sodium 11, 1s2, 2s2, 2b6, 3s1. Group 18, which is like helium, neon, argon, krypton, xenon, and radon, are called noble gas. Noble gas configuration refers to an outer main energy level full occupied, in most cases, by 8 electrons. Noble gas has an electron octet in its high energy level. So, noble gas have characteristic that all, or the outermost energy level, filled with 8 electrons. So noble gas is inactive gases, non-reactive. Why non-reactive? Because the outermost energy level was filled with 8 electrons. Like what? Like in neon. Look, neon 10, atomic number 10, 1s2, 2s2, 2b6. So energy level number 2 is filled with 8 electrons, 6 plus 2, 2 in S sublevel and 6 in B sublevel. So it's filled with 8 electrons. Neon, look here, 1s2, 2s2, 2b6. In second energy level, which is outermost energy, in second energy level, which is outermost energy level, filled with 8 electrons. Noble gas notation is the third way to use it for electron configuration. Sodium will have the configuration 1s2, 2s2, 2b6, 3s1. So we can use noble gas in electron configuration of sodium. Look, sodium, atomic number 11, while neon atomic number 10. Neon is a noble gas. Sodium 11 and neon 10. So we use this configuration with neon to write electron configuration for sodium. As the difference between neon and sodium, just one electron in 3s. So look here, the difference between the two configuration, what? Sodium one electron in the s sublevel, in third energy level, in s sublevel. Look, this is the difference. So we can remove all this and write, instead of 1s2 to s2 2b6, write 9 and then write 3s1. So this is electron configuration for sodium. Look here. 9 atomic number 10, while sodium atomic number 11. So 1s2 electron configuration for 9, 1s2 2s2 2b6. So we can remove all of those and write 9 and then write 3s1. 9 10 and here 1, so 10 plus 1 equal 11, which is sodium 11. Look, calcium atomic number for calcium, which is 20. So we can use a noble gas notation to write, or to electron configuration for sodium, for calcium, sorry. By what? We can write argon 18, argon atomic number of argon 18, then write 4s2. So 2 plus 18, which is equal 20, which is atomic number for calcium. Magnesium, look for magnesium 12. So we can use a 9, which is 1s 9 electron configuration for 9, 1s2 2s2 2b6, while magnesium 1s2 magnesium 12 2s2 2b6, then 3s2. So we can remove those, this and write 9 and then add 3s2. So this is a noble gas notation for magnesium. What about nitrogen? Nitrogen atomic number 7. So the electron configuration for nitrogen 1s2 2s2. So this is 4 2 2b3. What about helium? Helium is a noble gas but contain only 2 electrons in 1s2. So we can remove 1s2 and write helium and then add 2s2 2b3. So this is wrong. This one wrong. We should write it like this: helium 2, then 2s2 2b3. This is wrong. So noble gas notation for nitrogen 2s2 2b3. Helium, which is 2, 2s2 2b3. That's it. Thanks for watching.